Good morning, everyone. Welcome to our second session of our aerospace space track sessions for the Houston Tech Rodeo 2021. We are starting our second session today with building the future of space today. And we are very honored to have Mr. Matt Ondler, who is the Chief Technology Officer of Axiom Space, presenting today. Matt has a long storied engineering and project management career with NASA and other companies as an expert in robotics and systems, covering space robotics to underwater robotics, contributing to the success of many projects and including the success and growth of our International Space Station. Matt, welcome this morning. Thank you again for your participation, and I'm going to hand it over to you. If you'd like to add on to some of your history, that would be fantastic. Thank you, sir.
All right. Well, thank you very much. Always got to use one of the phrases of 2020 and 2021. Can you hear me okay?
Read you good. Read you good.
All right. Very good. Let me start sharing some slides, and then I'll start talking from there. All right. Well, it's a pleasure to be here, and really a privilege to chat with everybody. Always excited to talk about what we're doing at Axiom Space. And this first picture, this is a rendering of our space station that's being built off of the front node of the ISS. Last year, we won a very important opportunity that allows us to build our station off of the forward node of the International Space Station. And so I'm going to talk a lot about that in the next few slides. I'm the Chief Technology Officer at Axiom, but I have the fun job of building our engineering team and leading our engineering team. And our goal is to have all of the skills in-house that are required to build a spacecraft. So we've really grown about 10 times the number of people from a year ago, and most of those in engineering. And so it's been a fun ride the last year, and it's going to be fun the next several years as we continue to grow the team, grow our facilities and laboratories, and build this space station. So, usual disclaimer. You can tell by my picture that's not my hair blowing in the wind. But our vision for Axiom is to really build this thriving home in space that benefits every human everywhere. We think that there's a unique opportunity in commercial space to build products and services that help everyone on Earth. And we're doing that, as I mentioned. The first step is to build the world's first commercial space station. And as I go through the presentation, you'll hear what the advantages of building a commercial space station are versus a government-owned space station. So this is a shot, and I'll show some more, but this is a good one to start with. These are 3 of the modules that will fly to the ISS. And this little module, if you can see my cursor on the bottom, is what we call the Earth Observatory. It'll be a really, really unique place to view the Earth. And, you know, many astronauts that have had the opportunity to fly in space come back with a profound change in how they look at the world. And one of the things that we hope when we fly more and more people to space, and our goal is to democratize the flying to space, that people will have that profound change when they see the Earth from that vantage point and realize that there really is no country boundaries, and the world is one place where we all have to live and survive. So here's the plan. We're launching our first module in September of 2024, and then the second module arrives a few months later and is attached to the first module. And then the third module arrives and is attached, and it brings along this Earth Observatory. And then the fourth module that's planned to go to the ISS, go back one, is what we call the power thermal module. And it provides all the power, thermal control, and it has an airlock. So it allows us to then be independent of the ISS. Before that module comes up, we are plugged into the ISS. So we're getting power, thermal control, and at least through the second module, we're getting a communication link through the International Space Station. But once the power tower arrives, then we have the ability to separate from the ISS and be a free flyer. And then at that point, we'll continue to add modules to our station as needed. We think we'll be building modules that might be custom built for particular customers to scale up manufacturing. And so I'll talk a little bit more about that. We also think that we'll grab a few things that NASA wants to continue to operate as we separate. And these are important dates. You know, the official end of ISS life is 2026. The Biden administration has some efforts to extend the life of the station to 2030, but it won't survive much longer than that. It's just going to get too old and too hard to maintain and too expensive to maintain. And one of the advantages of a commercial space station for NASA is that it provides a platform, or we will provide a platform for NASA to continue to do research and technology development and fly NASA astronauts without the burden of maintaining a station. And so that frees up maybe as much as $3 billion a year for NASA to go off and spend that on something else, going to the moon and going to Mars. So it makes a lot of business sense for NASA as well to help us provide a commercial station. Here's our first module that we're flying. It has 4 crew quarters. The image in my background is in one of the crew quarters. Each crew quarter will have a large aircraft-sized window, and the modules have radial ports. There's 4 of them. There's one here coming out of the page, and then there's 3 others that are around this barrel section. And those radial ports allow us to add modules to each one of those ports. So really, it's a node that allows us to continue to build and add building blocks to our station. We will fly a docking adapter, and this is a standard NASA docking adapter, so it allows us to receive vehicles like the SpaceX Dragon or the Cygnus vehicle, any vehicle that has that same docking feature on it, we can accept to take crew and cargo. Here's a rendering of the inside, and one of the interesting things for me as an engineer, I've spent 28 years at NASA and a few other places after NASA, generally solving hard functional problems without paying too much attention to what the machine looked like. And so we're trying very hard to think about what the station looks like as well, so that we have a certain aesthetic, that we have a certain look and feel. If you look at a similar picture inside the International Space Station, it doesn't look like this. It's not quite as clean, and there's lots of wires running everywhere, and I often describe it as looking like a crazy person's garage. And some of that is because it's evolved over many years, but also because the particular user experience wasn't always focused on these sort of things. And one of the reasons we're interested in having it look more like this is we think it's easier to train crew, because some of our crew won't nearly be as trained as well as a NASA astronaut. So being able to find things, to have things more organized. We're also, I have this mantra that I tell my engineering team, that I want to be able to assemble and disassemble the station with just 5 tools. That, of course, is a bit of an exaggeration, but trying to minimize the number of tools so that there's common interfaces, so that when the crew operates the galley, the knobs and the interface is very similar to operating other parts of the station as well. Here's a shot of inside the crew quarters. We had designer Philippe Stark, who has designed it, and we're now off and building his vision and dream. We have a couple of these built here in Houston that we're trying out, different handholds and different mobility aids, trying out different material. The material's got lights integrated with it. And we're gonna, with a modern LED light, you can actually change the temperature and color of the light, which we want to do to help the crew manage their circadian rhythms. We think that's an important feature to provide better management of the crew health. And of course, each crew quarter will have a nice window looking at the Earth and infotainment center, as well as the ability to control the station where appropriate. Another shot of the original design from Mr. Stark. The third module that we're flying up is a research and manufacturing module. So it's much more utilitarian. So it's all about research, manufacturing. We want to be able to house heritage NASA experiments as well, but we're really designing infrastructure in a way that we hope will allow researchers to very easily fly payloads. It can be a bit arduous to fly a payload to the ISS. We want to build in utilities and capability where it's much more plug and play. So if there's a particular experiment that's running in a lab at Johnson & Johnson in Ohio, we want very little effort to be expended to take that same experiment and run it on our station and realize the benefits of microgravity. And so we're really building an infrastructure or the equivalent of an office park or an industrial park that will enable researchers and folks interested in manufacturing to come and use our station. You know, one of the things that I believe the value of a commercial station is that we are going to create things in microgravity that you can't create on the ground. And 20 years from now, we will not be able to imagine how we live without those things that we created in microgravity, whether they're new alloys or 3D bioprinting, perfect retinal implants, whatever that solution is going to be. There'll be a time in the near future where we can't imagine how we lived without it. And I think the benefit of the commercial station is that there were probably hundreds, you know, there have been very successful demonstrations of those sort of manufacturing on ISS. For example, there's a advanced fiber optic cable that has 100 times more transmission length that can be made in microgravity. There's some perfect retinal implants that corneal implants that have been demonstrated on ISS. But I believe there's probably hundreds of other ideas that never flew to ISS because the people that had those ideas had no place to go after the experiment, right? So they made some economic decision that, well, if I can prove out this technology, what good does it do me? Because I don't have any place to then go manufacture it at scale in space. And so a commercial space station doesn't have those limitations, and we have the ability to produce things at scale for customers. So I think that's going to create this flood of ideas and opportunities, some of which we can't imagine today. And it's going to create an amazing commerce in space because of that opportunity that a commercial space station brings. And as I mentioned earlier too, we think that we're going to be building entire modules perhaps for a single customer that wants to scale up the manufacturing idea that they've proven out in a module like this on a smaller scale, and now they want to build it at scale. I often think of it like the iPhone or a smartphone. You know, if you think about 10 years ago, it would have been impossible to imagine the applications that you now use every day on your smartphone. I think the same is going to be true. Once we build this capability, once we build this commercial space station that has all of these utilities and resources and capability, there will be lots of people that figure out interesting ways to use it that we can't imagine today. This is the Earth Observatory. It's the largest space window ever attempted. It's the largest space window in the solar system, pretty sure. This panel, the single panel, measures about 7 feet by 3 feet. So huge space window. This little picture on the side and this little video is we built a mock-up. One of the things that we believe in a company is building things, right? You can't sit around and think about what you're going to build, and can't sit around thinking about requirements. You have to go build things, test things, see what works, what doesn't, redesign, build the next thing. And so we've built a full-scale single window pane and have tested it under pressure and are evaluating the material. We're about to, on Friday, we're going to put it under pressure again and hold for about 20 days to see what our leak rate is on our current seal design. And I think this video just shows some early building up of the test. But again, this Earth Observatory is just going to be an amazing place to be and to observe the Earth, and incredible place for Instagram photos and things like that. So this is just the window frame being anodined, or alodined, I'm sorry. And again, Friday, we're going to pull a vacuum on the window material again and hold it for about 20 days to measure leak rate, try to understand some of the window properties. The window is what's called a stretched acrylic. And so anyway, a neat feature of our station, I think. And then the fourth module, and this one is very, very important, is the power and thermal module. And so it has a lot of the same kind of features, an interior with lots of systems, but it also has a 3-person airlock. So when we get the power thermal module, we'll have the ability to do spacewalks from our airlock. And then importantly, it has the large solar array that gets us the power that we really need to be on our own and to leave the ISS. And here's an example of simple advances in solar array technology. We can generate about the same amount of power as the ISS can with about 1/6 the area, just from advances in solar array technology over the last 20 or 30 years. And I think that's really, it's that sort of example and hundreds of others that are really enabling commercial space. You know, it's the things that NASA's figured out over the last 30 years on keeping humans alive for the long term in space, that we're leveraging all those lessons learned from the ISS. And it's really what the government should do, right? They should enable and foster the development of industries. And then with a commercial space station, then NASA has the ability to then move on to the next destination, you know, whether it's the moon or Mars. This shows a little bit of an assembly sequence. So one of the things that's interesting and different about our station relative to the International Space Station is that when you look at the International Space Station, most of these pieces were taken up on the space shuttle, and then on the Russian segment on a Progress rocket, and assembled, you know, in place. Our space station, each module is an individual spacecraft. So we get delivered to orbit either by a SpaceX Falcon Heavy or the Blue Origin New Glenn. And then our module has to fly to the ISS, rendezvous, and get inside the capture box, and then the robot arm on the International Space Station will reach out, grab our module, and then berth it to the first module to the forward node of the ISS. And then shown here, the ISS robot arm will walk off onto our module. So we have to have the same grapple fixture that is on the ISS. So the robot arm will walk off onto our first module in preparation of moving the docking adapter and then grabbing the second module and berthing it. So each module is its own independent spacecraft with its own GNC system, its own propulsion system, and flies and rendezvous with the station. And here's the research and manufacturing module, and it shows the Earth Observatory with the pedals closed on that launch. The arm will reposition the Earth Observatory to the bottom, again with the pedals closed. And then the power thermal module arrives, and this is in the launch configuration. So it's in a stowed configuration. And then this is with the solar arrays unfurled and the full extension. Now, we can't stay in this configuration very long, and actually this rendering sort of shows why. We shadow a great deal of the International Space Station, so we can't stay in this configuration very long. And so once we get to this deployed state, we will have to depart from the ISS. And then we'll be our own free flyer, and continuing to add modules and continuing to have cargo vehicles and crew vehicles arrive at our docking ports. And we'll be permanently manned at this point. In this configuration, we can house up to 8 crew. And as we add modules, that capability will increase. We might add modules that are specific for housing crew. And as I've mentioned a couple of times, we believe we'll build entire modules that are specific to a particular customer. And then, at this point, things really get interesting in that we might add inflatable modules to do some other activities. One of our business lines is media and product placement and being able to film movies and things like that. There's lots of customers that are very interested in that sort of thing. It's another example of something that NASA really is not allowed to do. And so we think there's a huge market for that kind of thing. And then we think also that we're going to construct modules in orbit. There's some really, really interesting large scale additive manufacturing technologies that we're partnering with. And so maybe we're printing modules, in space. And once you're able to do that, then you're not limited by the launch vehicle. It's, the kind of space station you can build at that point is really, whatever your imagination can imagine. And then this is our long-term vision. Most companies don't have a long-term vision. We have a 40 or 50-year long-term vision that we want to be able to build these kind of space stations in the future, where we're housing, hundreds, if not thousands of people, likely rotating to create some gravity. It's hard to keep people healthy for long in space. Once you get past 30 days, the crew has to exercise, up to 2 hours a day to keep their bone loss and muscle loss at a minimum so that they're not debilitated when they get home. And so that's hard to do when you're talking hundreds of people. So providing some artificial gravity to make that easier, to make living in space easier, is going to be important. And then there's going to be parts of the station that aren't rotating, so that's a pretty difficult mechanism. And so some of the kids in middle school will become the engineers that solve those problems, so that we can continue to have the microgravity available for the manufacturing that we hope to be doing there. So that's it. I'm going to leave it on this slide. Really, really appreciate the opportunity. I don't know if we have a Q&A section or not, but happy to take any questions.
Mr. Ondler, there is a question that was asked anonymously. It asked, what is the projected lifespan of the new ISS station, and how does it compare to the ISS?
Yeah. So we are designing for a 30-year life, but another feature of our station, because each module is an individual spacecraft, if one module reached its end of life or just was obsolete for whatever reason, we can separate that module by itself and then deorbit it and let it burn up in the Pacific Ocean. And that's something that the ISS can't do. When the ISS reaches into life, NASA will put the entire station on a trajectory into the Pacific Ocean. But with our station, with each module being an individual spacecraft, we can continue to refurbish and replace modules really for an unlimited time period. But in general, we're designing for a 30-year life. But we're also doing things like in our avionics system where we're really designing it like your home computer, where we want to be able to swap it out every 5 years and take advantage of advances in computing. So we're building a very modular system that's relatively easy to upgrade in certain areas.
Thank you.
Yeah, and one thing I forgot to mention, in you said International Space Station, it reminded me, one of the things that we want to do is we really want to open space for everyone in the world. And so some of our first astronauts that will fly will be from countries that don't necessarily participate in the ISS. The ISS has a large number of partners, but it's still relatively limited when you look at the countries in the world. And so there are a lot of countries that would like to fly professional astronauts because it brings prestige to the country. It helps stimulate science and technology and engineering and math in that country as well. And so that's an exciting part of our mission, I think, too.
Indeed it is. We have a question also from George Young, who asked, how assembled will the station be when it is flown up compared to being built in space?
I'm sorry, say that again?
How assembled will the station be when it is flown up compared to being built in space?
Okay. Yeah, each module will be outfitted and mostly ready to go. We will fly a crew up before the modules arrive, and so they'll reside on ISS until our module arrives, and then they will do some final plugging in and turning on and checking out of systems. But for the most part, each module will be assembled and kind of ready to turn on. And the first two modules have all of the life support systems, all the power systems, everything except for the ability to generate enough power. And that's why we plug into the ISS to get additional power. But all the life support systems and propulsion, GNC, all that will be outfitted on each module.
Thank you, Mr. Ondler. Got one last question, if you don't mind.
Sure.
How is design guided by today's research and still able to evolve to unknown future research needs?
Yeah, great question. And so our approach is to try to provide as much utilities as possible. So, for example, our payload accommodations, there's every form of power that you can get or that you would want, from 120 volts to 24 volts to USB plug-in. We're providing as many fluids as we can, so access to vacuum, nitrogen, oxygen. So trying to anticipate what particular researchers and payloads would require and provide as much utilities as possible. But there will always be some custom needs, and we're also building in the capability to accommodate those sort of custom payloads as well.
Well, Mr. Ondler, I know we've reached that time, but we really do appreciate the information provided today, and we appreciate you coming on and chatting with us.
Sure. No, my pleasure. All right. Thank you.
Thank you, sir, very much. You have a good day.
All right. Thanks.